Alright everyone, let's get to one more program for C language programming. Once again, very basic program, very simple program just for the practicing purpose. Again, we'll follow the same thing, source file, because we are mentioning the source code. We'll start with the heading with the two templates classes that will give us the comment, problem definition. Normally we should put the problem definition at the starting of the program. So as you can see here, the definition would be like a swapping of two variables. And again, to achieve that, we have certain methods, certain tactics. One of the methods we are going to implement, we'll start with regular routine, that is hash include. All the necessary header files we are going to add into it. Then, like our regular thing, the starting of the execution, that is nothing but integer main followed by brackets open and close. That is this particular part is known as the body of the program. Body of the program. Inside it, we mention one variable a with value 5, second variable b with value, for example, 7, and third variable which is nothing but our temporary holder. Okay, initially what we do is we simply print the values. Okay, like we say before swapping, and what will be the values before it? We want to print those values. Okay, so first value will come from a, second value will come from b. So this particular line printf statement will give you the printed values of a and b variables, which will be 5 and 7. Then we apply the swapping logic. That means we use the temporary holder. The value will go from a to c, from right to left. So now once the values are moved from a to c, we can move the value from b to a. So the values are safe again. Whatever the value was there inside a, it is now inside c, so it is already secure. Then the value inside b, now we are moving it into a, and finally we can put the value from c into a. So basically this will just give you the swapping part done. Very easy, right? Okay, so once we are done with that, we need the proof. So again we will print a and b both. Finally return 0. So when we try to run the code, we'll compile, but at the time of the compilation it will ask us to swap 1. Okay, so this is how we have saved the program. No errors, no warnings. That means we are ready to execute it. And when we run it, when we execute it, you can see clearly over here the values before, that is 5 and 7, and after the values are becoming 5 and 7. Like we say, just for proper /n, we can use /n so that the same program, the same output is visible in the next line. Not happening. Let's see why it's not happening. Okay, we can apply /n over here. Okay, let me see if it is okay. Okay. Yes, we have to compile it. Whenever we make the changes to the code, first thing we have to compile it so that it will make a new object file, and at the time of the execution this new object file is being executed. Yes, so don't make this mistake, right? Whenever you make any changes into your code, first thing you need to do is to compile so that it will become a new object file, and at the time of the execution the same object file is getting executed. So now as you can see, you are getting the proper output, the values after the swapping. Okay, another method, yes, for the same thing, but this time swapping is also getting done, but without using the third variable. Yes, there is also a variation, right? It's only for the logic development. There are so many methods of doing the same problem definition, attending a problem definition, and this is how we do it. We do it with so many multiple methods available to us. For this particular method, we don't need any extra variables. So value A will be holding 5 and B it will hold value 7, like that. Percentage D, again percentage D, that will be for A and B, but this thing is getting printed before we change it, right? Don't miss the semicolon at the end of the statement. Now is time for the logic part. See, the only constraint, the only condition is we don't use the third variable. So there are some different things. A equals to A plus B, then A B equals to A minus B, and like that ABA. That's how I recall it, you know. A minus B. Again, we need to do the same thing. Let me make it after. Yes, slash n, so that it is getting printed in the new line. Anyways, what is actually happening, you know, this is really very interesting. How? Because we are not using the third variable, it is all mathematical things are getting done. For example, A plus B. So whatever the addition is there, it is being stored into A. So A will be getting a new value. So new value of A, it will become 12. Then we come here. The new value of A, that is 12, minus B, which was actually 7. So the new value of B, it will become 5. And just like that, again, the subtraction, the new value of A, it is already 12. The new value of B is already 5. So this subtraction, the answer of this subtraction is getting stored into A. So the answer is nothing but 7, right? So let's execute it. Let's see it ourselves. So we'll go with the compilation, but before it will ask us to swap 2. Okay. Again, no errors, no warning. That means we are good to go. Let's execute the same code. See, it is functioning properly. So what I mean to say is there are so many methods of implementing the same problem definition, and it is just an example of that. Okay, I hope it was a very good session.